Welcome back to another video. In this video, we will be discussing on how to create an ontology using Protege. If you want to know more about web ontology language, check out my previous video on this topic. I'll add a link in the description below. If you end up liking this video, please leave a like and hit the subscribe button. Thank you for watching. Stay tuned. So this is Protege. It is a free software for getting started with ontologies. The version which I am using is OWL 5.5. To check your version, you can go to Help, About, you can see your current version. The first thing what we are going to do is set up our ontology IRI. University. Now let us look at how to import axioms into our ontology. Importing axioms is useful when you want to reuse entities from an already existing ontologies or when you want to merge ontologies. Now I have a basic ontology with the creator details and some classes. Let us look at how we can import them. To import axioms from another ontology, you need to open the ontology in the same window as your current ontology. So for that, File, Open, Yes. Now I have two ontologies open. This is a basic ontology and this is our ontology. Now in my basic ontologies, I have some axioms defined and also some classes. Let's import this into our ontology. For that, I go to Refactor, Copy, Move, Delete Axioms, Axioms by definition, annotation property. I'm copying the DC terms creator license along with the classes. Continue. It will show all the axiom properties that we are copying. Continue. You can either copy, move or delete. I'm choosing to copy it to another ontology. You can use this if you are copying and making a new ontology, or if you are copying to already an existing ontology, you can go to the second option. We are selecting the second option over here. Continue and select the ontology. So university is the ontology to which I am copying. So I am selecting university, finish, and it says axiom successfully copied. Now if you go to our ontology, we can see the axiom has been copied. Now since we use DC terms over here, I'll be adding DC terms to ontology prefixes as well. To do that, adding it, DC terms, and now I'll add the annotation, the creator name, language, English. If you want to enter multiple languages, you can enter with any of the following languages. And if you want to specify any license for your ontology, you can just select license and give your license type. You can also add websites to this by giving the creator name, and you can add your website over here. Now I'll give a description for this. For that, I go to comment and city, language, English. Okay. When we go to classes tab, we can see all the axioms that we have imported from the basic ontology. You can click and drag if you want to rearrange something. If multiple people are working on an ontology, or if you want to track the changes made by a person on an ontology, you can do that by going to File, Preferences, New Entities Metadata, and check these two options. Annotate new entities with creator and annotate new entities with date and time. What this will do is, when you enter a new class, for example, I'll go subclass of staff, academic, it will automatically indicate the creator name and the date when it is created. So this will be easy for tracking purposes. Now to add classes, just select a class, and this is to add subclasses, and this is to add sibling class. Sibling class means both the classes will be in the same hierarchy. For example, I'll give subject as a sibling class of course. Subject. You can see both will be in the same hierarchy. If you want to make subject as a subclass of course, you can create subclass and subject. As you can see, subject has now become a subclass of course. You can delete by just selecting and deleting. Now let's add two classes for our staff class. I'm adding it as subclass, academic staff and administrator. Now academic staff is a subclass of staff and administrator will be a sibling class of academic. So I'll click on academic, then go to sibling class and then type in administrator. And we can say academic is disjoint with administrator because academic staff takes class where administrative staff is responsible for the management of the university. So to make them disjoint, what we do is we select either of the class. I'm selecting academic, disjoint with over here administrator. Now we've made academic to be disjoint with administrator and click OK. Now if you go to administrator, you can see that it has automatically been disjoined with academic class. Now there's another method to enter classes into Protege, that is using the class hierarchy. To create classes using class hierarchy, select the main class below which you want to enter the hierarchy. In this case, I'm selecting thing because thing is the superclass of all classes. I'm going to create my hierarchy under thing. For doing this, I'll go to tools, create class hierarchy, and you can enter the hierarchy required. So I'm entering this hierarchy. University with course subclass and subclass of course accountancy, business management, computer science, electrical, mechanical, and sibling class of course is department with two departments. Continue. Do you want to make subclasses disjoint? I'm unchecking this. Finish. And you can see our class hierarchy has been created. So subclass of thing is university, and university has courses, departments, jobs, person, academic. Let's rearrange this part. Academic is staff, administrative is staff, all the others are student. University course and the different courses offered by the university, the two different departments in a university, the different jobs available in a university, the different people in a university comprising of students and staff. Staff has academic and administrative staff, and students we have UG, PG and PhD students. Okay, so basic class definition is done. Now let's try and visualize our ontology. For that we go to OWLviz. And you can see your ontology. To view the full ontology, you can just click this button. It will show all the class and definitions in our ontology. We have made academic and administrative as disjoint classes. Academic and administrative as disjoint classes. Now let us see how to create an equivalent class. For that, we are making assistant professor and professor as an equivalent class. To do that, select one of the classes, go to equivalent to, assistant professor. Now assistant professor will be equivalent class of professor. If you go to assistant professor, you can see professor. Back to visualization. Click this button to see the full ontology. So this is the full ontology that we created. If you want to export the full ontology, you can go over here and click this. This will export the ontology as an image. Asserted. Next. Select the type you want to export. Next. And you will have your full ontology. Okay, in case if this is not coming properly, or if it is coming as a small cluttered image over here, this is probably because you may not have an OWLviz package installed. So what you need to do is install the OWLviz package and then go to File, Preferences, OWLviz, and make sure this path is properly specified. Once that is done, you may need to save and restart the software for it to start showing. Now that we are done with classes, we will move on to properties. In Protege, we have two types of properties: object properties and data properties. Object properties are used to define relationship between classes, and data properties are used to define relationship between a class and a literal value. Let's start with object property. As we said, object properties are used to relate to classes. So let's start with an object property, admits. Now admits is used to relate university and student, such as a university admits a student. So let's define the domain and range for an object property, admits. Domain, university, and the range will be student, because university admits students. Similarly, let's define some more object properties. As you can see, enrolls is an inverse property of R enrolled by. This means that if A is an inverse of B, then B is an inverse of A. So we'll add this for our object property. R enrolled by inverse of enrolls for. Let's define some more properties. You can customize the different tabs or views over here by going to Windows and Views. For example, if I want to add this description window, I'll go to Window, Views, Object Property Views, and Description. And wherever you click, you can get the window over there. Similarly, for tabs, you can add tabs, and whichever tab you want, you can add it. Now that we've defined some object properties, let's define some data properties for our ontology. To do that, we head over to data properties. And data properties are used to define the relation between classes and literals. To define a data property, and the range will be an integer. We are showing the relation between a class and its literal value. To add sibling property, you can click this button, and to delete a property, you can deleted by this button. Now if you want to add comments over here or in object properties, you can go to annotations and comment. Select the language and OK. Let's define some more data properties. To rename, you can go to label and this will change the label of the data property. Similarly for classes, if you want to rename, you can either change the label or you can right click and change IRI name. And this will change the IRI name of the class. You can do the same for object properties as well. Now that we have defined object properties and data properties and have created our classes, let's run the reasoner to ensure that ontology is consistent. To run the reasoner, go to reasoner, select one of the available reasoner. I'm choosing Hermity reasoner and click on start reasoner. Now if we have defined all the axioms properly, the reasoner will not show any error, and you can see it over here. If there is some error in our ontology or if there is some inconsistency in our ontology, we'll see a small dialog box over here with a warning sign indicating that there is some inconsistency in our ontology. Now if there is any inconsistency in our ontology, the reasoner will show an error over here. The software will give us where the inconsistency has occurred. Now let's go to define some individuals. For individuals, we can define the subject, the courses, the student's name, the staff name, etc. Let's create an imaginary university called Stark University. Define a course and a department. So engineering as a type of department, and Stark University is our university. Artificial intelligence as a type of course. Now we'll define a student. Peter, who has enrolled for AI, has. You can use Ctrl and space to autocomplete over here. Peter enrolls for. Let's give him an ID number. Now this type what you give here should be matching to what we have given in the data properties. Now ID number, what we given is type of string. So when we define an ID number over here, make sure to select string, otherwise it will throw an error. As ID number, now he has credit 440 credit as integer, so I'm selecting int. Here subjects, string. Now I'm going to change type to a PhD students. To do that, I'm just going to remove this type assertion, select it, student, PhD student. Similarly, we can add more individuals. After defining all the individuals, we run the reasoner once again. Excellent. Now as we can see, we have run the reasoner once again after fixing the error, and currently there is no error and the ontology is consistent. That brings us to the end of the video. Thank you for watching. If you like what you watched, please leave a like and hit the subscribe button as it encourages me to make more videos. Thank you once again and see you in the next video.